Yellowstone National Park sits atop one of the most awe-inspiring and misunderstood geological features on Earth, a supervolcano. For decades people have called it dormant, implying it's a sleeping giant unlikely to stir. But that's a myth, and recent discoveries about the size and nature of Yellowstone's magma chamber are rewriting what we thought we knew. This isn't just a story about rocks and lava, it's about a dynamic, living system that could shape the future of our planet. Let's start with the basics. A supervolcano isn't just a bigger version of your average volcano, it's a geological titan capable of eruptions so massive they can alter global climate. Yellowstone's last major eruption, about 640,000 years ago, ejected over 1,000 cubic kilometers of material, enough to bury entire states under ash. That event created the Yellowstone caldera, a massive depression in the Earth's crust that's still active today. But dormant? Not quite. The idea of Yellowstone being dormant comes from a misunderstanding. People hear it hasn't erupted in hundreds of thousands of years and assume it's inactive. But volcanoes don't work like light switches. Yellowstone is very much alive, and the key to understanding its activity lies beneath the surface, in its magma chamber. Scientists have long known Yellowstone sits above a vast reservoir of molten rock, but recent studies have revealed just how enormous this magma chamber truly is. Using advanced seismic imaging, researchers have mapped a system far larger than previously thought. The magma chamber is a complex, multi-layered beast, stretching across two main regions. The upper chamber, closer to the surface, holds partially molten rock, about 9% melt, according to studies. This upper section alone contains enough magma to fill the Grand Canyon 1.5 times. Below it lies a deeper, larger reservoir, with less molten material but still incredibly significant, potentially holding enough magma to fill the Grand Canyon 11 times over. That's right, 11 Grand Canyons worth of magma. Let that sink in. The total volume of this system is estimated at around 46,000 cubic kilometers. To put it in perspective, that's enough material to cover the entire United States in a layer of ash 3 feet deep. This isn't a small, contained pocket of lava. It's a colossal, sprawling network that makes Yellowstone one of the most closely watched geological sites on the planet. But size isn't the only factor. The composition and behavior of this magma matter just as much. The upper chamber's high melt percentage means it's closer to being eruptible, though it's still far from the 50% melt typically needed for an eruption. The deeper chamber, while less molten, acts as a heat source, feeding the system and keeping it active. This dual-chamber setup explains why Yellowstone is so dynamic, with geysers like Old Faithful, hot springs, and frequent earthquakes. These are all signs of a restless volcano, not a dormant one. So, why the dormant label? It's partly because Yellowstone's eruptions are rare. The supervolcano has had 3 major eruptions in the last 2.1 million years, roughly every 700,000 years. The most recent was 640,000 years ago, so some argue we're due for another. But that's not how volcanoes work. They don't follow schedules. Smaller eruptions, like lava flows, have happened more recently, around 70,000 years ago, and these are far more likely than a cataclysmic supereruption. Still, the sheer scale of the magma chamber means we can't ignore the potential. Let's talk about what an eruption could mean. A supereruption would be catastrophic. Ash would blanket North America, disrupting agriculture, water supplies, and air travel for years. Global temperatures could drop by several degrees, triggering a volcanic winter. But here's the reality check. The odds of a supereruption in our lifetime are vanishingly small, less than 0.0001% per year by some estimates. Smaller eruptions or hydrothermal explosions are more plausible, but even those are rare and would likely be localized. Scientists monitor Yellowstone around the clock using GPS, seismometers, and satellite data to track ground deformation and earthquake activity. The volcano's behavior is predictable to an extent. Sudden changes in the magma chamber would trigger measurable signals long before an eruption. Right now, the data shows Yellowstone is active, but stable. The ground rises and falls as magma and gases shift, but there's no sign of an imminent eruption. What's fascinating is how these discoveries reshape our view of Yellowstone. It's not a ticking time bomb or a dormant relic. It's a living, breathing system, constantly evolving. The magma chamber's size and complexity show us the Earth is far more dynamic than we often give it credit for. Yellowstone's hot springs, geysers, and earthquakes are all part of a geological symphony, driven by forces deep within the planet. The takeaway? Yellowstone's supervolcano is neither asleep nor on the verge of catastrophe. It's a powerful reminder of Earth's raw energy, a place where beauty and danger coexist. By studying its magma chamber, we're not just learning about Yellowstone, we're unlocking secrets about how our planet works, and that's a story worth telling.